Hello everyone, how are you all doing? I hope you all are doing good. In today's video lecture, we are going to continue a topic from chapter Measurement of Matter. So, starting with chemical symbols of elements. Now, Dalton used certain signs which represented certain elements. For example, a circle with dot inside it for hydrogen and C for copper, right? So today we are using these symbols determined by International Union of Pure and Applied Chemistry, which is also shortly called as IUPAC. These are official names and symbols are used all over the world. The current method of choosing chemical symbols is based on the method invented by Berzelius. Now, what was the method given by him? According to this method, the symbol of an element is either the first letter or the first and second letter or another specific letter in its name, right? For example, uh, if it is hydrogen, then H. If it is copper, then for cuprum it is Cu, right? For sodium, for natrium, it is Na, right? So such letters are used to symbolize the element's name. The first is always a capital letter and the second one is small letter. Followed? So who has given this method? Berzelius. Now, molecules of elements and compounds. Atoms of some elements such as helium, which is a group 18 element, right? Non-reactive one. Neon have independent existence, means they are not dependent on other elements. They are capable of existing on their own without undergoing any kind of reaction. It means that these elements are in a monoatomic molecular state. Monoatomic means, mono means single, atomic means one. So they are just comprising of one atom. Sometimes two or more atoms of an element combine to form molecules of that element, right? In such elements, they are in polyatomic molecular state. Poly means many and atomic means atoms, okay? So there will be more than one atom. For example, the elements oxygen, nitrogen are in a diatomic molecular state. Diatomic means comprising of two atoms. For example, O2, N2 respectively. Please, it is a subscript, just make that correction while you write. O2 is oxygen, right? So it is again an element which will be in a polyatomic molecular state or diatomic molecular state, because that is how it is more stable. When atoms of different elements combine with each other, the molecules of compounds are formed. Here, diatomic, monoatomic molecules were there because there was only one element. For example, in oxygen gas, there both elements are oxygen only, correct? Whereas here, these molecules will have two different elements combining together. So, in other words, compounds are formed by chemical attraction between different elements, not the same elements. Followed, right? Compounds are also molecules but of different elements. Now, moving on to the next, that is molecular mass. The molecular mass of a substance is the sum of atomic masses of all the atoms in a single molecule of that substance. Followed, whatever atomic masses are there for a particular element, that atomic mass will be considered. Molecular mass again will be expressed in the unit Dalton, because that is how atomic mass is also expressed. Followed, in the previous slide, in the previous video, I have already given you the value of 1 unit as well, 1 unit of Dalton. So suppose if I have to deduce the mass of water molecule, how am I going to do that? So you can make a table like this: molecule, then its constituent elements, then their respective atomic masses, then the number of atoms present in that particular molecule, then atomic mass multiplied by the number of atoms present in that molecule, will give you the mass of particular element, and then you can total it up. You will get molecular mass. Let us see the molecular mass of water. So in water, constituent elements are hydrogen and oxygen, right? Again here it should be H2O. So atomic mass of hydrogen is 1 and oxygen is 16. Number of atoms of hydrogen are 2 in water and 1 of oxygen. So if you see the atomic mass of hydrogen, it will be 1 into 2. So the mass of constituent of hydrogen will be 2. If you see oxygen, the number of atoms in the molecule is 1. So if we multiply atomic mass by number of atoms, so it will be 16 into 1. So mass of constituents will be 16. When you combine hydrogen's mass and oxygen's mass here, you will get 18 as the molecular mass. So for molecular mass there is a formula, sum of constituent atomic masses, right? So the formula is given. You can use this formula for compounds like carbon dioxide, carbon monoxide, hydrogen peroxide. Please, for your practice, do that at home. Moving on to the next, that is mole. It's a very important concept. Please understand it well. When elements and compounds take part in chemical reactions, it is the atoms and molecules that react with each other, and therefore it is necessary to know the numbers of atoms and molecules, right? However, while carrying out a chemical reaction, it is convenient to measure out quantities that can be handled instead of counting the numbers of atoms and molecules, because every time you cannot keep on counting the number of molecules, correct? So we need to know a certain weight in which the number of molecules will be constant. For example, we know that in a dozen there are 12 units. So certain things you don't have to keep on counting. You can just know one particular unit, and you know that the number of molecules present in this particular unit will always be same. That is why the concept of mole is useful for this purpose. A mole is that quantity of a substance. Mole is a quantity, okay? It is not a number, correct? Like it is a number, but it is a quantity which has a particular number which is constant. Followed? So a mole is that quantity of a substance whose mass in grams is equal in magnitude to the molecular mass of that substance in daltons. So for example, if hydrogen is 1 unit, if you take that in grams, so hydrogen 1 unit is equal to 1 gram. That will be your molar mass of hydrogen, not molecular mass. How much? It will be your molar mass, because it is mass of 1 mole. So 1 mole of hydrogen is equal to 1 gram of hydrogen. And thus, the molecular mass of oxygen is 32 units, and therefore 32 gram oxygen is 1 mole of oxygen. Followed, students? If you take the unit mass into grams, it is 1 mole of that particular element or that particular molecule. The molecular mass of water is 18 units. Therefore, 18 gram of water makes 1 mole of water. Followed? So what is mole? Mole is the mass taken in grams. Followed? Now 1 mole of a compound is the mass of that substance in grams, equal in magnitude to its molecular mass. So the SI unit of mole is mole, MOL, without T. Okay. So how do we calculate the number of So the number of moles of a substance which is given by small n is equal to mass of substance in grams upon molecular mass of the substance. Correct? For example, if you take 18 grams of water, correct? So you have to write 18 grams upon molecular mass, that will be 18 units, correct? So 18 by 18 will get cancelled out, so number of moles of that substance will be 1, that is water. Followed, students? Now moving on to the next concept, that is Avogadro's number, which is in connection with mole only. Now we are saying that 1 mole is the mass taken in grams of a particular substance. If you take 1 mole of any substance, the number of molecules in that particular mass is fixed, right? So the number of molecules in 1 mole of any substance is constant. The Italian scientist Avogadro did pioneering work in this context. Therefore, this number is called as Avogadro's number and is denoted by a symbol N subscript A. Okay, please make that correction. Later, scientists demonstrated experimentally that the value of Avogadro's number is 6.022 into 10 raised to the power 23. Now, what is this number? This is the number of molecules which will be present in particular given mass. So 1 mole will always have 6.022 into 10 raised to the power 23 molecules. How in 1 dozen you always have 12 units? That 12 units can be of anything. It can be of pen, it can be of pencil, it can be of pineapple, whatever it is. Here also 1 mole of any substance will have fixed number. What is that fixed number? 6.022 into 10 raised to the power 23. What is the symbol for this number? N subscript A. This is known as which number? Avogadro's number. Who has done this work? Italian scientist Avogadro. Okay, a short note is asked on Avogadro's number. Just as a dozen has 12 items, a century has 100, or a gross has 144, a mole will always have 6.022 into 10 raised to the power 23 molecules. Followed. For example, a mole of water, that is 18 gram of water, contains 6.022 into 10 raised to the power 23 molecules of water. So is it clear, students? So now how many molecules are there in 66 gram of carbon dioxide? Let's take. So molecular mass of carbon dioxide is 44. Now we already know the formula for number of moles. So mass of carbon dioxide in grams, how much it is? 66 grams. Then molecular mass 44. So if you divide that, you get 1.5 moles. So how many molecules we have to calculate? 66 gram of carbon dioxide means 1.45 moles. So 1 mole of carbon dioxide contains 6.022 into 10 raised to the power 23 molecules. Now we know that this number is fixed. So how many 1.5 mole of carbon dioxide will be? So what you will do? The answer is very simple. 1.45 mole of carbon dioxide contains 1.5 into 6.022 into 10 raised to the power 23 molecules. Once you multiply that, so 6 into, first you can do 6 into 1.5, so that will be around 9.033 into 10 raised to the power 23 molecules. Followed, students, what is done? We have calculated the number of molecules in 66 gram of carbon dioxide. What we have is weight, okay, and what we have to calculate is number. So how is this number and weight related, number and mass related? By the molar mass. Followed, students? Always remember that the number of molecules in a given quantity of a substance is determined by its molecular mass. Also, the number of molecules in equal masses of different substances different. 1 mole quantities of different substances have different masses measured in grams. I hope the topic is clear to you. There are few examples in your book which you have to practice. Okay. Thank you so much, students, for watching the video.